Welcome to a journey into the vibrant world of rainbows, the magnificent spectacle of nature. These radiant arcs of color painting the sky are more than just a beautiful sight. They're a fascinating blend of science and art, a testament to the wonders of light and water. In this video, we'll unravel the science behind rainbows, delve into their colors, explore their historical significance, and even learn how to anticipate and capture them. So, fasten your seatbelts as we dive into the fascinating science behind these arcs of color. Rainbows, as mesmerizing as they are a beautiful play of physics. Like a captivating piece of art, they are created when sunlight and rain combine in a very specific way. To understand this, let's start with sunlight. Sunlight, or white light, is actually a mix of different colors. These colors are the same ones you see in a rainbow, and they are always in the same order. This is because each color has a different wavelength. Now, imagine a rain shower just ended and the sun is peeking out from behind the clouds. The sun's rays hit the raindrops lingering in the air. Inside these droplets, the rays of sunlight bend or refract, and then bounce or reflect off the inside surface of the raindrop. As the light exits the droplet, it refracts again. This refraction causes the light to spread out and separate into its different colors, a process called dispersion. The light is refracted again as it leaves the droplet, and this bending and spreading of light results in the band of colors we see as a rainbow. The whole process, from the sunlight entering the raindrop to it exiting, happens in a fraction of a second. And it's happening in countless droplets at the same time. That's why we see a full arc of colors in the sky instead of just a single point of light. The colors of a rainbow always appear in the same order, with red on the outside and violet on the inside. This is because each color of light bends at a slightly different angle. Red light bends the least, so it's on the top, and violet light bends the most, so it's on the bottom. But here's an interesting fact. No two people see the same rainbow. This is because the appearance of a rainbow depends on where you're standing and where the sun is in the sky. So, the next time you see a rainbow, remember it's a little bit of sunlight having a grand adventure. Ever wondered why a rainbow has those specific 7 colors? Well, it's all about the science of light. When sunlight, which is white light, passes through a prism, or in this case, a raindrop, it splits into its constituent colors. This process is called dispersion. Think of light as a team of athletes running a race. The finish line is when they exit the raindrop. Now each color of light is like a different athlete. They all run at different speeds. Red light is the slowest, so it refracts or bends the least. On the other hand, violet light is the fastest, so it bends the most. The other colors, orange, yellow, green, blue, and indigo, fall somewhere in between. This spread of colors from red to violet forms what we call the visible light spectrum. Now, you may be asking, why do I usually see red on the outside and violet on the inside of the rainbow? This has to do with the angle at which the light exits the raindrop. Red light exits at a larger angle compared to violet. Hence, we see it on the top of the arc. Thus, the beautiful spectrum of colors we see in a rainbow is the visible light spectrum, displayed in all its glory. Rainbows have not only dazzled our eyes, but also our imaginations for centuries. This awe-inspiring phenomenon has been steeped in mythology and symbolism across diverse cultures, creating a rich tapestry of stories and beliefs. In Norse mythology, for instance, the rainbow was seen as a bridge named Bifrost, connecting Earth to Asgard, home of the gods. It was guarded by the god Heimdall, who would blow his horn at the arrival of unwelcome guests. Over in the ancient Greek world, the rainbow was personified as the goddess Iris. An emissary of the gods, Iris was believed to use the rainbow as a bridge, swiftly delivering messages from the heavens to mortals below. In Aboriginal Australian culture, the rainbow is tied to the dream time and the rainbow serpent, a powerful and ambivalent deity responsible for creating and shaping the landscape. Meanwhile, in the Judeo-Christian tradition, the rainbow is a symbol of God's covenant, a divine promise never to destroy the earth by flood again, as recounted in the story of Noah's Ark. In Hawaii, rainbows have a deeply rooted cultural significance. They are seen as a pathway for the alii, or the royal class, to ascend to the heavens. Rainbows continue to inspire modern symbolism too. They represent peace, diversity, and hope, as seen in the LGBTQ+ pride flag. From divine messages to bridges to the heavens, rainbows have been a source of wonder and inspiration across cultures. Science has taken our understanding of rainbows to new heights. Our exploration of visible light and its interactions with water droplets has not only clarified the origins of the classic arc of colors we associate with rainbows, but also unearthed a host of less common yet equally awe-inspiring phenomena. Consider the double rainbow. This captivating spectacle occurs when light is reflected twice within a droplet, producing a secondary arc with colors in reverse order. The space between the two rainbows is darker because of destructive interference, a phenomenon known as Alexander's dark band. Then there are circular rainbows. Though not typically visible from the ground due to the horizon's interference, these full circle displays can be seen from high altitudes or when looking down on a water spray or fog bank. Finally, let's touch on supernumerary rainbows. These softer pastel arcs appear on the inner edge of the primary rainbow. They're caused by the interference of light waves that have traveled different paths within the raindrop. These are just a few examples of the diverse array of rainbow phenomena that modern science has helped us to understand. Each of these wonders is a testament to the complex and beautiful interplay of light, water, and our atmosphere. These rare and fascinating rainbow phenomena remind us of the endless wonders of nature. Want to capture a rainbow's beauty in a frame? Let's dive into some essential tips. First, understanding when a rainbow can appear is crucial. They typically show up when there's rain and sunshine simultaneously, usually in the early morning or late afternoon. The sun needs to be at your back and the rain in front of you. Now, to photograph them, a wide-angle lens is your best friend. It can help you capture the full arc of the rainbow. Remember to play with the exposure settings, as rainbows can be faint or vibrant. Overexposing the shot might wash out the rainbow, while underexposing can help the colors pop. And don't forget about composition. Try to include some interesting elements in your frame, like a landscape or a landmark. It adds depth and context to your rainbow shot. So keep your camera handy and your eyes on the sky. You never know when a rainbow might just pop up. So there you have it, the wonderful world of rainbows in a nutshell. From the science of their formation to their historical significance, the vibrant colors they display, and even how to capture them on camera. Remember, each rainbow is a spectacular light show put on by nature itself, and they're out there waiting to be discovered. So, after the next rainstorm, why not venture out and seek them? We invite you to subscribe, like, and share your rainbow experiences or questions in the comments below. Until next time, keep exploring.